Smart energy meter. What's the first thing that comes to your mind after hearing this word? Do you think there will be a meter equipped with sensor and digital displays evolved from those analog coil based meters? Or a meter equipped with Wi-Fi, email and messaging services like a smartphone or other smart devices available these days? Or a meter smart enough to detect when the user is trying to bypass the measurement unit so it can punish them? Now let's compare the developments in the field of energy meters. In the late 90s, Electricity Board used to install the meters with the coil and rotor based mechanism for measuring the power consumption, which are now replaced with digital meters with sensors and memories which can store the data and also capable of recording faults or any attempt to bypass it. But what is lacking in these is that meter readers have to visit each and every house for generating the bills and later records are maintained in the offices. But to overcome such problems and improve bill collection system nowadays, prepaid meters are in trial. In those meters, each unit is connected to the servers for the maintenance purposes. But establishing such a network in a country like India is not feasible. Such connectivity cannot be provided at all locations for their functioning. So now let's have a look on what we have attempted to do. We have made energy meters that are capable of creating their own network for the purpose of communication. These meters are installed at every house in a locality which will be interconnected with each other and share their data. And at last, this data will reach up to the power station. By implementing this, we may overcome the issue of connectivity.
Now let's have a look on the components that we used in our project. First one is ACS 712. It is a fully integrated Hall effect based linear current sensor. It is simply put forth as a current sensor that uses its conductor and measure the amount of current applied. Now the second component that we used is ESP8266 serial Wi-Fi wireless transceiver module is self-controller SoC with integrated TCP IP protocol stack that can give any microcontroller access to your Wi-Fi network and capable of either hosting an application or offloading all Wi-Fi networking function from another application processor. Third one and the last component, LED interface I2C, is a 16x2 I2C interface LCD which is used for displaying variable parameters. As you can see, the meter is stabilizing the connection with the other unit. And as you can see, it is displaying 0 units. That means currently no load is connected to the output or no power is available. Each user is assigned a unique customer ID which is used as a primary key in our database. As we have seen that no load was connected to the meter, so 0 units are being updated on the Google Sheets, which we have used as our database. Now we have connected the output to the load, which can be seen on the LCD display, and same is being reported on the Google Sheets. This the user interface developed for the management of the power system. Live data updated on the interface with total consumption, top defaulters and other useful information. Since it is in demo mode, we have not worked upon change of rate feature which can be done as and when needed. We can generate the bills and send them to the user's registered email ID, which is demonstrated here. We have provided the same email for both the users in the demonstration, so bills received on the same email.
Till now, you had a look on what and how of our project. Now let's dive deep into the modules and have a look on how things are being managed at the heart of the unit. First, begin with the running code running on the module which is acting as a server. First, we imported certain libraries which are responsible for handling the operation of the devices involved. Then, created the instance LCD for handling the LCD display. Then define the static IP, gateway and subnet with desired SSID and password which will be used to access this server. Then define the variables for handling the update from clients. Here we have provided the SSID and password for the Wi-Fi to establish an internet connection. Here we define the host and port for connecting to Google Sheets. Here we provide the guest ID for the Google Sheet which is acting as a database in our project. These variables are used in power consumption, measuring and storing them. This variable millivolt per ampere is defined to calculate the current as our current sensor returns 185 millivolts for every 1 ampere. Now moving on to the setup function. First we started the LCD and printed welcome on it. Then started the module in dual mode, that is access point and station with provided static IP and other parameters, and assigned the SSID and password which defined earlier. Then we set up two addresses and directed the server to their respective function. First, handle index function. Here we printed the units value that is being received from the clients, which means when we trigger this IP in browser, it will display units value on the screen. And the other function, handle update. Here we have read the argument that are being passed from the client and we received units and ID in units and ID variables respectively. Then return updated to the client for confirmation. Then we added these received values and concatenated them with guest ID and created an URL and pushed the data to Google Sheets. Now let's continue with setup function. Then we started the server and printed the result on display. Then here we connected the module to Wi-Fi for accessing the internet with the SSID and password provided earlier. Now let's look on loop function. Firstly, we called getVPP function, which is voltage peak to peak. In this function, we initialize some variables, then read the value that is being returned at the sensor pin, which is A0 in our case. Then read the maximum and minimum values from crest to troughs in case of an current, AC current, and return the result. Then divided that value by 2 to calculate the amplitude of the wave, then found the voltage RMS value and evaluated the RMS value of current. Here the millivolt per ampere value is being used to get the result. This 0.07 is the zero correction, as sensor was returning this value at no load, and stored the units to variable, then printed the customer ID and units consumption on the LCD. Then checked the connection status, then concatenated the units and ID of the server with the gas ID of the seat and pushed to the Google Sheets. This completes the code running on the server side. Now let's explore the code running on the client side. We started by importing libraries and creating the instance LCD for handling the LCD. Then assigned the SSID and password and host of the server. These variables, same as we have seen in the server side code, used in measuring power and storing units. Now in setup function, started by initializing the LCD and connected to server and print the result on LCD, then made sure about the connection. Now in loop function, first we measure the power as explained in the server side code. Here we checked the connection status. Then send the request to the server with ID and units as arguments. This getVP function is same as servers. This completes the code on the client. This is the code responsible for the software that is power management system. This is developed in Python language with the help of these modules. First, tkinter module is responsible for user interface, which is imported, and imported message box feature for showing warnings and information. Then we imported pandas module for manipulating our database, which is Google Sheets. Gspread module helps in accessing the Google Sheets directly on Google server. SMTP module is used to send emails and establishing a connection with the Gmail server. Email message module is used to format the email with desired subject, content and attachments. Then date and time for filtering data by months and date. Here we have created root window with desired height, width and colors. Then some variable for storing the values and updating them on UI. This function is used to access the Google Sheet. Here we are updating the labels on UI after calculation. This function is executing when change rate button is clicked. This shows the warning in a message box that this can't be changed. This function is for generating the bills and sending email. Here we are formatting the email with email message module with a subject and body. Then we connect it to Gmail server with SMTP library and sent mail, and displayed the message on the display with the message box. This function is used to format the UI and other outputs. And these labels are responsible for creating the UI that we have seen.